Hi guys, we're solving this chemistry paper today. This is 9701 paper 1-2 May June 2023. A lot of you have requested chemistry papers. I will be solving all of them soon. Paper 1, paper 2, paper 4 as well as paper 5. I plan to complete all of the papers. Maybe there are 4 plus 6, 10 in total by the end of December. If you do need them urgently before the October-November series, please do comment below and do consider supporting me on Patreon. It is CAIE Paper Solved, patreon.com/CAIE Paper Solved. I'll put the link in the description. There are 3 tiers. The lowest tier, it's just for supporting me. The middle tier and the ultimate learning experience, where you get access to one-on-one video meetings with me like once or twice a month, and access to private uh, videos on particular topics like for physics, chemistry, math, and bio. That's work in progress though, and your name in the credits on the screen on all of my YouTube videos, and priority for question paper solving requests. You also get access to all my notes for physics and chemistry, as well as all the solved um, question papers for chemistry, paper 1, 2, 4, and 5, as well as physics and bio. And for math, you get access to M1, P1, P3, and S1, ranging from 2002 to 2020 to 2023, basically. And yeah, for the second tier, you get access to the notes and some question papers, some solved question papers, the latest ones. Alright, without further ado, let's begin. Before we start, let's take a look at the threshold. So for paper 1, 2, it was quite hard. A was at 27, B was at 23, C was at 19. Okay. So the full mark is 40. A was at 27, B was at 23, C was at 19, D was at 15, and E was at 11. Okay. So A star should be at around 4 marks higher than this, which is 31, because it follows a trend of 4 marks, as you can see clearly. So let's start. I do need one thing though before we begin. I need the periodic table. Wait, let me bring that over here. I know that it's down below, but it's not horizontal here. Okay, let's start. When chlorine gas is analyzed in a mass spectrometer, 35 chlorine 35 ions are detected. Which row is correct? Number of neutrons in chlorine 35. So chlorine has a proton number. We know that proton number can't be changed, of 17. So that is the proton number of chlorine. So the number of neutrons should be 35 minus 17, which is 18. So there are 18 neutrons. These are wrong. And the electronic configuration, since there are 17 protons, should be 1s2, 2s2, 2p6, 3s2, 1, 2, 3, 4, 5. So that is, since it's in the 5th group or 17th group and 5 electrons are covered, it is 3p5 since it's in the 3rd period, right? And in the p block, 5th element in the p block for that particular period, so it's 3p5. However, that is a chlorine atom. For a mass spectrometer to analyze anything, we need to turn it into a cation, so it has 1 less electron. As a result, it turns into 1s2, 2s2, 2p6, 3s2. Instead of 3p5, turns into 3p4 because it lost 1 electron. So we're going to go for 1c. 2. Which species is a free radical? To be a free radical, you need one lone pair. Sorry, not one lone pair actually. one unpaired electron, right? Excuse me. So helium is basically, um, you know, in the is the second element, and it has two electrons in its outer shell. It has one lone pair, but not one. It's a noble gas, but it does not have unpaired electrons. On the other hand, beryllium. Let's look at beryllium. Beryllium is the fourth element, as you know. So beryllium is 1s2, 2s2. However, look at this. If you consider the beryllium anion, what does it turn into? 2p1. So this is full orbital. This is a full orbital. But this, on the other hand, is an unpaired electron, which is why I'm gonna go with B. On the other hand, why not oxygen? Oxygen is over here, which is 1s2, 2s2, 2p4. So O2 minus is 1s2, 2s2, 2p6. So it doesn't have any unpaired electrons, right? That is why the answer is beryllium anion. Which statement is correct? The first ionization energy of chlorine is more than the... Sorry, I just need to check my audio. Yes, it's fine. So the first ionization energy of chlorine is more than the first ionization energy of argon. No. Basically, the trend is like this. So for the third period, right, chlorine is in third period, it's like this. It goes up, it's a 1, 2, then it goes down 3, 4, 5. It goes down again 6, 7, 8. So the noble gas has the highest ionization energy rather than lower one than the seventh one. So A is wrong. Second ionization energy of calcium is higher than the second ionization energy of magnesium. However, look at this. Calcium is below magnesium in the group, and we know that as we go down the group, ionization energy actually decreases. So this is wrong. Calcium does not have a higher second ionization energy than magnesium since it is below magnesium in the group. Next, the second ionization energy of sulfur is equal to the first ionization energy of phosphorus. No. Basically, I told you, phosphorus is like in group 15. So phosphorus is over here and sulfur is over here. Sulfur has actually a bit lower IE than phosphorus, mainly due to the fact that it has two electrons in its p orbitals, which results in electron pair repulsion, right? So C is also wrong. So the correct answer must be D. The eighth ionization energy of chlorine is more than the first ionization energy of neon. So neon is over here and chlorine is over here. So if we did compare the first one, then neon would probably have a higher one. Obviously have a higher one, but the eighth ionization energy of chlorine, that's kind of insane. Like we are testing its limits, right? So there's no way that the eighth isn't higher than the first ionization energy of neon, because progressively, since we are taking 8 electrons, right? What does that mean? Chlorine is in general 1s2, 2s2, 2p6, 3s2, 3p5. If you take 7 electrons, it turns into Cl7 plus, which is 1s2, 2s2, 2p6. That's it. And neon is also at 1s2, 2s2, 2p6. They have the same electronic configuration, but look at this. This is attracting. We are taking the electron from a shell within, and it has more protons compared to neon, even though they have the same electronic configuration. So chlorine will attract more heavily, and yeah, it will have a higher ionization energy. Okay. Number 4. If 1 mole of hexane combusts in excess oxygen, how many moles of products are formed? Okay, so hexane, C6H12. Sorry, that's hexane, C6H12 plus 2H14 plus excess oxygen gives you CO2 plus H2O. Okay, so it's going to be 6 here and it's going to be 7 here. So what's the moles of the products? 6 plus 7 is 13. That's it. Separate, and if you want to balance oxygen, it's going to be 7 plus 12, 19. So that's 19 by 2. Okay. Separate samples, each of mass 1 gram, are listed with an excess of dilute acid. Which compound releases the largest amount of CO2? So CaCO3 plus a dilute acid. Maybe, yeah, we can go for excess of dilute acid. So it might be, HCl but dilute. So we actually end up with CaCl2 plus H2O plus CO2. And yeah, to balance this, we need a 2 over here. That's it. Now, we need the largest amount of CO2, right? So hear me out. We have 1 gram of this. What is the MR of calcium count? It's 100.1, I think. Calcium is 40.1, and I know the rest. I have it memorized. 40.1 plus 12 plus 48 is 100.1. So 1 by 100.1. That's the moles. Now the molar ratio is going to be 1:1. So same moles times 24 dm cube. So or times 1000. That is 239.76 cm cube. Okay. Now let's go to the next one. We'll try lithium carbonate. Li2CO3 plus HCl is equal to Li lithium chloride plus CO2 plus H2O. 2 over here, 2 over here. So essentially it's the same thing. So basically we are going to divide one. The balancing is going to be the same. We always have 1 mole of carbon dioxide, same number of moles of the uh, products, and same number of I meant to say the carbon dioxide and the carbonate, regardless of what carbonate we have, we'll have the same number of moles. Now to find that out, we just need to do mass by MR. So let's find out the MRs. So the lower the MR, the greater the number of moles, right? So the one here with the lowest MR should be the correct answer. So let's check lithium carbonate. CO3, it is actually 16 times 3 plus 12, which is 60. And for the metals, let's check lithium, 2 lithiums. It's 6.9 times 2, right? 6.9 times 2 plus 60, which is 73.8. And for this we had 100.1. For MgCO3, I think it's 24.3. Yeah, 24.3. 24.3 plus 60, which is 84.3. And for sodium carbonate, it's actually 23 times 2, which is pretty high. 23 times 2 plus 60, which is 106, the MR. 106 is the MR. So clearly the highest MR is for D, so it produces the least CO2. And yeah, lithium carbonate has an MR of 73.8. So yeah, the denominator is smaller, but the whole fraction is much higher. So I am gonna go for 5B, because all of the equations are the same regardless of being group 1 or group 2. The moles of CO2 and the moles of the carbonate itself will always be the same. Which statement about the ClNO molecule is correct? Let's see. The ClNO molecule. Each molecule contains one sigma and 2 pi bonds. No, 1 sigma here, 1 sigma here. 2 sigma and 1 pi. 2 sigma, 1 pi. Okay, so that's wrong. It's a non-polar molecule. That's wrong, actually. Because these two dipoles are different. They are not the same. If you had oxygen on both sides or chlorine on both sides, and nitrogen also has a lone pair, right? It's in group 5, right? So it has a lone pair. So yeah, it's not linear. It is not linear because nitrogen has a lone pair, so there will be repulsion. Nitrogen has 5 electrons in total in the last shell, so there will be repulsion. It is actually, sp2 hybridized, but not 120 degrees, just a bit less, like 117. The nitrogen atom is sp2 hybridized, correct. How did I determine that? It's determined by the number of bond pairs plus lone pairs, and I only consider sigma bonds. So there are 2 sigma bonds, so 2 bond pairs and 1 lone pair. So 2 plus 1 is 3. If you ever get 3, the hybridization will be sp2. If you got the hybrid, this is called the hybridization number. If you ever got a hybridization number of 4, it would have been sp3 hybridization, right? Like water, ammonia, then methane, those ones. Next, number 7, which row is correct? Um, CO2 is in fact linear. The total number of pairs of electrons in the valence shell of the central atom. It has a double bond over here. No, it actually has 4 pairs, so this part is wrong. BF3 is in fact trigonal planar. BF3, 1, 2, 3 pairs, right? And no other lone pairs. So yeah, all of this is correct. The shape is wrong. It should be pyramidal. And PF5 should not be octahedral. It should be a triangular bipyramid. Okay, that's why it's wrong. And yeah, this should have been, 5. They gave information about SF6 in 70. Number 8, the volume of a vessel is this. It contains pure argon at a pressure of 1 into 10 power 5 pascals and at a temperature of 25 degrees Celsius. So under these conditions, it can be assumed that argon behaves as an ideal gas. So we can use the ideal gas equation, which is PV equals to nRT. So yeah, remember the units, 1.00, it should be pascals and volume should be in meter cube. N is, we don't know N. R is 8.31, it is given in the last page, and the temperature should be in Kelvin, so it's 25 plus 273 Kelvin. Okay, so let's do the math. 1 into 10 to the power 5 times 1.2 into 10 power minus 3 divided by 8.31 divided by 25 plus 273. So yeah, N is actually 0.04846. Now to find out mass is basically moles into AR. So what's the AR of argon? It is, you can't see, 39.9. Okay. Answer into 39.9, which is 1.93. I'm gonna go with B, 8B. That's fine. Now a student mixed 25 cm cube of 4 mole per dm cube HCl with an equal volume of 4 mole per dm cube sodium hydroxide. The initial temperature of both solutions was 15. So we had HCl and NaOH, and we actually mixed how many actually? Moles? 25 by 1000 into 4.1 moles of each. We got NaCl plus H2O. The initial temp was 15, the max temp was 30. The heat capacity of the final solution can be assumed to be 4.18, and the density can be assumed to be 1 gram per cm cube. Using these results, what is the enthalpy change? So we are going to use H is equal to mc del theta, where the mass will actually be, for acid-base neutralization reactions, remember that you need to take the total mass of the solution, which is 25 with an equal volume, 25. So that's 50 cm cube, which is converted to 50 grams. The specific heat capacity is 4.18, and the change in temperature is actually from 15 to 30, which is 15 degrees Celsius, 30 minus 15. So it's 15 times 50 times 4.18. This is the total heat energy release, 3135 joules. Now, to find out the enthalpy change, you need to divide by the number of moles of the limiting reagent. However, both of them have the same number of moles. No one is limiting. So enthalpy change del H will actually be equal to 3135 divided by 0.1, because for zero point 0.1 moles, if it is 3135 joules, then for 1 mole, how many will it be? How much will it be? Sorry, 3135 by 0.1. And of course, I'm going to convert the joules to kilojoules by dividing it by 1000. This is the rule of thumb. Okay, you will get this typically. So I'm getting an answer of 31.35. Let's see if there is an answer like that. Yeah, 31.35. Closest answer is B. And yeah, the minus should be included obviously, because there was a temperature rise, which means that energy was being released to the surroundings. All right. Number 10, nitrogen monoxide is rapidly oxidized to nitrogen dioxide. Nitrogen dioxide can then dimerize to form dinitrogen tetroxide. What is the value of the standard enthalpy change for the reaction shown? Which one? This? Oh, okay. So let's see. 2NO plus O2 is equal to N2O4. So we are dealing with enthalpy of formation. Interesting. So this reaction shown has two parts actually. Firstly is this 2NO plus O2 is turning into 2NO2, and then 2NO2 is turning into N2O4. This is the gist of the reaction. Okay, this has an enthalpy change of minus 58. And our starting reagents are nitrogen and oxygen. We need 2 molecules of that. Now, this is a bit of a different Hess cycle because there are multiple steps involved. I know this way, and I have the enthalpy of formation of NO2 as well. I know this arrow as well. I see. Okay. So on the left hand side, we want to make NO2. Sorry, we want to make NO, which is 91, which is 91 times 2. And on the right hand side, when we make NO2, it is actually 34 times 2. So we want to find this out first. This is del HR. If we find that out, then we can actually find out the one for the total reaction, which is this one in total. Interesting sum. Okay, so I'm going to find out del HR first. We know that 91 times 2 plus del HR is equal to 34 times 2. So 91 times 2, and there are 34 into 2 minus answer, which is minus 114. Del HR equals to minus 114. Now the total one will be minus 114 minus 58 from here to here, right? So I'm getting an answer of minus 172. I actually haven't seen a sum like this ever, okay, in the QP. So yeah, you might get any type of sum. It just needs to click at that moment. Because look, it was a typical Hess cycle. I did do it this way because I saw that I have NO2, I have NO, and I also have this reaction over here. But they wanted the whole thing, so I just realized that, okay, so maybe after finding out del HR, I need to just add this up because, you know, for when it forms a dimer, right, there is an enthalpy change. So I just added it up and we got an answer of, you know, minus 172. Interesting question. I liked it a lot. Okay. Question number 11. LiAlH4 contains AlH4 minus ions in which aluminium has an oxidation state of +3. LiAlH4 reacts with water as shown. In this reaction, each of the 4 water molecules produce 1 hydroxide ion. It does this by losing 1 H plus ion, which reacts with the LiAlH4. Which changes in oxidation number occur in this reaction? Okay, so lithium is always +1. Never forget. Okay, lithium is always +1 since it's group 2. And hydrogen is always +1 except in metal hydrides. This is a metal hydride, so it's going to be -1. The total will be -4. Aluminum is +3 over here. Lithium is +1. Hydrogen is 0 over here. oxygen is -2, hydrogen is +1. Okay, hydrogen is -1 here. Here aluminum is +3. Oxygen is -2, hydrogen is +1 over here. So essentially, in this reaction, each of the 4 water molecules produces 1 hydroxide. It does this by losing 1 H plus ion, which reacts with the AlH4. So the trick here is aluminium does not change. Okay, that was the trick. Only hydrogen changes. Check it out. Hydrogen went from -1 over here in lithium aluminum hydride to 0, right? And yeah, each of the water molecules produces 1 hydroxide ion. What does this mean? Basically, water is composed of H plus and OH minus. So the hydrogens in water, the ones with +1 power, did not change. Look, they produced hydroxide, where hydrogen has an oxidation number of +1, oxygen has an oxidation number of -2. -2 plus 1 is -1. As a result, these 3 hydroxides and this OH, they come from this H2O. As a result, I can say that nothing happened to the hydrogens over here. They were +1 before, now they are still +1 in all these hydroxides, okay? You need to understand that. So what happened to hydrogen? These hydrogens changed. These 4 hydrogens in lithium aluminum hydride, they had an oxidation number of -1 and it turned into 0 for when it turned into the element. So it went from -1 to 0, so it increased by 1. So H increases by 1 is what I'm looking for. H increases by 1. H increases by 1. H increases by 1. Okay, now it's between B, C, and D. Now, what about the other ones? If you take a look at this, they said that, AlH4 minus ions in which aluminum has an oxidation number of +3. How many hydrogens do we have in total, right? We have 4 hydrogen atoms over here and 8 hydrogen atoms over here. So out of these 4 hydrogen atoms, all of them changed. We have 8 hydrogen atoms over here, right? So all these 4 changed. 4 hydrogen atom changed from -1 in lithium aluminum hydride to 0. So they increased by 1. But we need the total of 8, right? 4H2 means 8 hydrogen atoms. So that means 4 hydrogen atoms from water. This is from lithium aluminum hydride and this is from H2O, must. A change from +1 to 0. So what does that mean? They also decreased by 1. So increased by 1 as well as decreased by 1. This was in fact tricky. 11 is C. You had to, see the math whether it was correct. It had to add up to 8. So clearly 4 from lithium aluminum hydride, 4 from H2O, and all 4 water molecules actually lose hydroxide ions. We know that each water molecule is composed of H plus and OH minus. The OH ions remain intact, but the 4 H plus actually decrease their oxidation number from +1 to 0. Very interesting sum. I like this. Next, number 12. The vanadium salt VOSO4 is soluble in water and reacts readily with powdered manganese in dilute sulfuric acid. The equation for the reaction is shown. Which statement about this reaction is correct? Hydrogen is oxidized in the reaction. Let's see. There's +1 over here, still +1 over here. Wrong. Manganese is the reducing agent in this reaction. Our reducing agent is oxidized itself. So manganese went from 0 to +2. So since manganese was oxidized in this reaction, that obviously means that manganese is the reducing agent. Okay? That's it. Sulfuric acid did not get changed at all. Okay? 13, in which equilibrium with an increase in pressure at constant temperature increase the yield on the right hand side. So let's check the number of gaseous moles. It has 1 over here, 4 here, and 5 here. So if we increase pressure, the equilibrium will shift to the side which has less number of moles. So can't be 1, but the answer is clearly B, since I have 5 on the left but 4 on the right. So if I increase pressure, the equilibrium will move to the right hand side which has less number of moles, 4, to restore equilibrium. Number 14. Hydrogen iodide is added to an evacuated reaction vessel. The vessel is sealed and warmed. A decomposition reaction occurs. Hydrogen and iodine are formed. Some hydrogen iodide remains. Okay. When equilibrium is established, the total pressure is 1.2 times 10 to the power 5 pascals. The partial pressure of hydrogen is 4 into 10 power 3 pascals. Hydrogen iodide, hydrogen, and iodine are all gaseous under the conditions used. What is the value of Kp for the equilibrium at this temperature, assuming the decomposition is the forward reaction? Okay, so hydrogen iodide decomposes to form hydrogen and iodine. Now, all of them are present. Now, the formula for Kp is going to be the partial pressure of H2 times the partial pressure of iodine divided by the partial pressure of Hi whole square. Now, hear me out. We have the partial pressure of hydrogen. So what's the formula for partial pressure? Partial pressure of hydrogen is actually equal to the mole fraction of hydrogen times the total pressure. So we can write that, 4 times 10 to the power 3 is equal to the mole fraction of hydrogen times the total pressure, which is 1.20 into 10 to the power 5. I don't think we needed to do this, but I'm still showing you 10 to the power 3 divided by 1.2 into 10 to the power 5. So the mole fraction of hydrogen is in fact 1 by 30. No, I think we needed to do this. Okay, so if Hi decomposes, it will form equal moles of H and iodine. Okay, because according to equilibrium, that is how it's gonna act. Since it was like, maybe it had x initially, these were 0, now these are y, and this is x minus 2y, right? Now this mole fraction 1 by 30 is for hydrogen. It will also be for iodine, and on the other hand, the mole fraction for Hi after equilibrium is established will be, 30 minus 2, which is 28 by 30. Okay, now let's do this. We can write that it is basically 1 by 30 times the total pressure into 1 by 30 times the total pressure divided by 28 by 30 times the total pressure whole square. So overall, the total pressures get cancelled out because I have 2 total pressures above and also 2 total pressures below. Now ultimately I end up with 1 by 30 whole square divided by 28 by 30 whole square. Now I finally get 1 by 784, which is 1.28 into 10 to the power minus 3. This was rather complicated. You needed a good understanding of equilibrium or KP/Kc to figure this out. Interesting sum, actually. The questions are actually evolving, I'm not kidding. I haven't seen these before. These aren't common questions. You needed a lot of IQ to solve these. The equations for two reactions are shown. The two reactions have similar reaction mechanisms. The initial rate of reaction X is greater than that of reaction Y when measured under identical conditions of temperature, pressure, and reactant concentration. Which statement explains this difference? Rate of X is greater. Okay, so the activation energy for X is less than Y. That is 1 point in favor of it. If activation energy is less, then rate will be high. So yeah, 1 seems correct. I am gonna look for options with 1. It's between A and C. For 2, the Br bond is weaker than the Cl bond. So look, we are actually making the Br bond. It is true that the Br bond is in fact weaker than the chlorine bond, but how does this help us? In this reaction, we are trying to make the bond. So, you know, if it was on the left hand side, right? If bromine was on the left hand side, if it was like 2NO plus Br2 is equal to 2NO Br, that would have been relevant because we were trying to break the bond then and we would need to give less energy compared to chlorine. However, in this particular reaction, we are not trying to break the Br bond, rather, we are trying to make it. So, it having a weaker bond energy is actually a hurdle for us. Alright, that is why it can't be 2. That's why I'm just gonna go for C. Okay, so a bond being weaker is only beneficial to you if it falls on the reactant side, because we would give less energy, we would need less energy to break it, yeah? Let's still take a look at 3. A higher frequency of collisions between molecules of NOBr occur than between molecules of NOCl. That's not right because all the conditions are the same, temperature and concentration. So the same number of collisions occur. It's just the number of successful collisions that might differ due to having different activation energy, okay? So 15 is C. 16. The diagram shows the Boltzmann distribution of energies in a gas. The gas can take part in a reaction with an activation energy E. The gas is maintained at constant temp. Which statement is correct? If a catalyst is added, the peak P will be lower. No, the peak remains same, okay? Just EA moves to the left. So more molecules have energy greater than EA. So yeah, it should be C. P is only affected by temperature, okay? 17. L, M, and N are 3 different elements from period 3 of the periodic table. L is the element whose atoms have 3 unpaired electrons in its 3p subshell. Okay, let's bring the periodic table again. But yeah, I get why A was at 27. It is quite challenging, this whole paper. So there in period 3, L is the element whose atoms have 3 unpaired electrons. So for period 3, 3 unpaired electrons. This is L. Phosphorus is L. Okay, 3 unpaired electrons. Next, M is the element with the highest electrical conductivity. So the graph goes like this. Sodium, magnesium, aluminium, right? And then yeah, silicon is alright, it's a semiconductor, and the others are just really bad. So aluminium is M, highest electrical conductivity, 3 electrons for each cation, for each atom in the sea of delocalized electrons, Lm. And N has the highest melting point. So what's the graph for highest melting point? Sodium is pretty low, then we have magnesium, then aluminium, and silicon is the highest, then we have phosphorus and the others, okay? So yeah, it's silicon, LMN. Silicon is this, okay. So what do they want? Which statement about L is correct? About L, phosphorus. Phosphorus has a higher atomic number. No, it has the highest atomic number out of all of them, right? Next, L has lower atomic number. No, this is also wrong. L has a higher atomic number than both of them. 100% correct. 18. In reactions 1 and 2, X represents an element in period 3. In each reaction, X is forming a product where X is the highest oxidation number. Which ratios show a steady increase from sodium to phosphorus? I need to read the question again. In reactions 1 and 2, X represents an element in period 3. In each reaction, X is forming a product where X is in its highest oxidation state. Okay. Which ratios show a steady increase from sodium to phosphorus? Okay. So NaCl, and we can get PCl5. And for oxygen, it is Na2O to P2O5. Fine. Now, which ratios show a steady increase? So this one is Y to Z. So the Y to Z ratio, this one, it is basically, 1:1, and here it is 1:5. Here is 2:1, and it turns into 2:5. So let's check this out. P is to Q, right? So I actually did Y is to Z, right? And P is to Q, but they're asking Z is to Y and Q is to P. So it would just reverse. This is P is to Q, so Q is to P would be 1:2 turns, sorry, yeah, 1:2 turns into 5:2, which is increasing. And this goes from 1:1 to 5:1, which is also increasing. So I'm gonna go for both. Okay, 19. Sodium, magnesium, aluminum, silicon, and phosphorus are all elements in period 3. Three statements about the oxides and the chlorides of these elements are given. The ionically bonded oxides all react with dilute hydrochloric acid. So silicon oxide and phosphorus oxide, we know that those are acidic oxides. So 19, one can't, the answer for 1, let's check this. The ionically bonded oxides all react with acid. So we have Na2O, then MgO, Al2O3. These are ionic, so yes, they all react with hydrochloric acid. But the other ones like SiO2, this is covalent. Then P2O5 or P410, those are covalent, right? So those this is correct because the ionic ones do react with HCl. One is fine. All metal chlorides produce neutral solutions when added to water. This is actually wrong because NaCl produces a neutral solution, but MgCl2 produces 6.5, a solution with pH 6.5. Aluminum chloride is worse. So 2 is wrong. Okay, 2 is wrong. So we only get this as an answer. The two most electronegative elements, both form covalently bonded chlorides. Yes, 3 is correct. Because as we go to the right of the periodic table, we know that electronegativity increases. The table compares calcium with barium and calcium carbonate with barium carbonate, which is correct. Thermal stability. As you go down the group, thermal stability increases. So barium carbonate is more stable. Next, reactivity with water. As you go down the group, the size increases. The valence electron is more further away, so it is more easily lost. As a result, barium is also more reactive. Okay. Last 20. Solution P and Q each contain a different group 2 ion at the same concentration. One contains Mg2+, the other contains Ba2+. Tests are carried out on 5 cm3 samples. Test 1. Add 1 cm3 of 0.1 mol per dm3 Na2SO4. Test 2. Add 1 cm3 of 0.1 mol per dm3 NaOH aqueous. Okay. So for sulfate, we know that the solubility of sulfates in group 2, for sulfates, solubility decreases. So BaSO4, in test 1 there will be more precipitate with Ba. And for hydroxide, we know that barium hydroxide is soluble, but rather magnesium hydroxide is less soluble. So we are going to get a precipitate. 21 is B. J dissolves in water to give an aqueous solution K. K gives a dense white PPT when aqueous silver nitrate is added. So this is basically AgCl, this PPT. So K has a chloride ion. So J dissolves in water to form aqueous solution K. J might be NaCl. Next, when heated with aqueous potassium hydroxide, K gives off a gas that turns moist universal indicator paper blue. So yeah, that gas is alkaline in nature. Ammonia is released. This is the test for ammonia gas. So K has the ammonium ion as well as the chloride ion. So it must be ammonium chloride, yeah? Test for ammonia positive, test for chloride positive. Ammonium sulfate and ammonium nitrate are used as fertilizers. These salts have different percentages by mass of nitrogen. They have the same effect as each other on the pH of wet neutral soil. Which row is correct? Both of them are, they are used as fertilizers. So what do? They add nitrate, right? However, you know that ammonium salts are acidic in nature, so they will decrease the pH of salt. And which one has higher percentage of nitrogen? Let's see. Nitrogen is, 14 exactly, I think. So for ammonium sulfate, it is 14 times 2 divided by 14 times 2 plus 8 plus 32. Sulfur is 32 or 32.1? 32.1. Doesn't matter though, honestly. Oh man, wait. Plus 4, 16 is 64. This is one. The other is 14 times 2 divided by 4 plus 14 times 2 is 28 plus 48. Clearly, it's looking like the one below, right? Clearly. %. Still doing it for you guys. 28 divided by 28 plus 8, 32.1 plus 64. This is 21.2%. Okay. So we are gonna go with, ammonium nitrate. It's better. So both decrease, and ammonium nitrate has higher percentage. The equation shows a reaction that occurs between carbon monoxide and nitrogen monoxide in a catalytic converter. Which statement is correct? The catalyst used is finely divided iron. So this, in a catalytic converter, we typically use platinum, rhodium. These are the ones we use. So it is not iron that's used in Haber process. The reaction prevents greenhouse gas emission into the atmosphere. No, wrong. Carbon dioxide is a greenhouse gas. The reaction reduces the possibility of formation of photochemical smoke. Right. NOx, nitrogen oxides, NOx, these form photochemical smoke, so C is correct. The reaction results in increased ozone depletion. Wrong. For ozone depletion, what do we need? CFCs, chlorofluorocarbons. Those aren't being produced here. Okay, we move on to organic from 25 onwards. Which compound has this molecular formula? C6H10O. So C1, 2, 3, 4, 5, 6. That's fine. We have one oxygen. For hydrogen, let's count 1, 2, 3. This has 3 hands. 4, 5, 6, 7, 8, 9, 10. Yeah, 25 is A. I won't bother looking at the other ones because I already found my answer. But I can show you still. Look at this. This is gone because 1, 2, 3, 4, 5, 6. It has one oxygen. Look at the hydrogens. 1, 2, 3, 4, 5. This is 4 hands. 6, 7, 8, 9, 10, 11, 12. See, that's a lot. The general formula for a non-cyclic alcohol is this. How many different structure formulas are there for N3 and 4? Let's see. C3H7OH, which is basically, CH3, CH2, CH2OH. That's one. While the other is for 4 carbon, that's CH3, CH2, CH2, CH2H, butanol. Structure isomers, not stereo. So this one is basically 1, 2, 3 for OH. That's one. And then we can go for, that's propan 1 ol. We can go for propan 2 ol. And we can go for branching. Can we though? It just has position isomers, right? So it has to be 2. And for this one, we have 1, 2, 3, 4 OH bond here. For position, we have butan 2 ol. There you go. And now for chain, there are multiple. Okay. For example, check this. What if I just take one hand? What if I take this hand and bring it here? What does it turn into? This is 1, 2, 3. This is propan 1 ol, but 2 methyl propan 1 ol. What if I do this? You know, what if we do this? This one. We have to take the longest chain. So that's a 1, 2, 3. This is 2 methyl. Wait, how many? Yeah, this is fine. Like basically what I did was, see this over here, this hand? I essentially erased this and brought it over here after erasing it. So this is actually propan 2 ol, but it's 2 methyl propan 2 ol. So we have butan 1 ol, butan 2 ol, then 2 methyl propan 2 ol, and 2 methyl propan 1 ol. So in total, I think, yeah, we have these 4. You're gonna get better with practice. You need to learn all the combinations. So it's 2 and 4. Compound X has 1 chiral carbon atom. It produces bubbles with Na but not with Na2CO3. So it's not a carboxylic acid. But it reacts with sodium, so it's an alcohol. So 1 chiral carbon. So let's check this out. CH3C, CH3, OH, COO, CH3. This does not have a chiral carbon, so it has to be B. OH, CHH, CH, CH3, COO, CH3. So yeah, this one is chiral over here. That's why the answer is B. Let's end the paper. I'm super sleepy. It's like 1:09 a.m. I have class tomorrow. The things I do for you guys. Ethane reacts with an excess of chlorine in the presence of UV to produce a mixture of products. Ethane, okay. CH3, CH3. How many of these products contain 2 carbon atoms and 1 or more chlorine atoms? So we can get CH3, CH2Cl, CH3CHCl2, CH3CCl3. Having the chlorine over here on this carbon would be the same thing, right? Then we can also get CH2Cl, CH. This compound and this compound are the same. So I'm just gonna do this. Why don't I do this first? CCl3. I'm doing the CCl3 ones first. CCl3, and we might have CH and Cl, and then Cl2 completely. We might have Cl3, and here's CCl3. So that's 1, 2, 3. Now let's do all the other combinations. These are the CH3 combinations, right? All CH3 combinations over here. Now, what if I keep like 2 on each side, right? What if I do this? CHCl2, CHCl2. So I did 0 1 0 2 0 3. I also did 1 3 2 3 3 3. I also did 2 2. What am I missing? We did 2 1. Did we do 2 1? We didn't do 2 1. We did 2 3 though. Okay, so 2 1. Now we need 2 1, so which is CHCl2 and 2 1. So CH2Cl. I don't think we had this before. 2 1. So are we done with all the combinations? We have 0, all the ones with 0, all the ones with 3. Now for 2, the unique ones were, we did 2 0 and 2 3. So the unique ones were 2 2 and 2 1. So in total, I think we have 1 2 3 4 5 6 7 8. It feels like I still need to check. But yeah, these look like the ones. However, did we do 1 1? Oh, I've missed 1 1. Sorry, my bad, guys. That was the combination I was looking for. It's 1 1. So that means 2 2 1 1 3 3. These are the ones we need. So that's CH2Cl, and on this side we have CH2Cl. Okay. So it's 0 1 0 2 0 3, 3 1 3 2 3 3, and 2 2 2 1 and 1 1. So I think the better way to do it would have been like do it with 0 first, then do it with 1 1 1 1 2 1 3, do it with 2 2 1 2 2 2 3, then do it with 3 3 1 3 2 3 3. I didn't do it with 0 anymore because it's already done. Okay, but now look at the ones which are common. We already did 3 2 once because 2 3. We already did 3 1 once. 3 3 is unique, 2 2 is unique, 1 1 is unique, and we did 1 2 or 2 1 first. Okay, so in total we have 1 2 3 4 5 6 7 8 9. Sorry for taking some time with that. Just had a brain freeze. That might happen in the exam, or you might just mark 8, but the correct answer would have been 9. That might happen. All right, next, number 29. When bromoethane reacts with hot ethanolic NaOH, a colorless gas is formed. Ethanolic NaOH is used for elimination reactions. The gas decolorizes aqueous bromine, so it's an alkene. So bromoethane, which is CH3CH2Br, it will form CH2CH2, which is ethene after the elimination reaction. What is the colorless gas? This ethene. Alkynes are hydrocarbons that contain one triple bond. Like alkenes, alkynes take part in addition reactions. A saturated compound can be formed. For example, ethane reacts with an excess of hydrogen to form ethane. Propine, C3H4, which is like this. C3H4 undergoes an addition reaction with an excess of hydrogen bromide in 2 stages. Markovnikov's rule applies to the addition of HBr to each stage. Okay, where is the main product obtained? Alright, so this carbon over here has more alkyl groups. So the second product would be like this. We would be getting, we know that the from HBr, Br will go to the carbon which has more alkyl groups. So CH, H, Br goes here, CH3, and then further this turns into CH3, CBr, CH3, Br. So yeah, it is CH3, CBr2, CH3. That's how it goes. CH3, CBr2, CH3. I'm gonna go for 30D because Markovnikov's rule applies. Bromine reacts with alkenes by electrophilic addition mechanism, in which a cation is formed as an intermediate. Which mixture will produce the most stable intermediate cation? Okay, ethene plus bromine. No, no, no. Clearly no. We need a tertiary, right? We need a tertiary carbon. So check this one out. What is this? 3,3 dimethyl pent-1-ene. So pent-1-ene, which is a CH2, 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 CH3. 1, 2, 3, 4, 5. 3,3 dimethyl. So this is carbon number 1, 2, 3. So CH3, CH3. Here you go. 3,3 dimethyl. So listen up, this is just to trick you. Since it's not on carbon 1 or 2, it won't help with stability. A is also wrong. Now methyl propene, what is this? CH2, C, CH3, CH3. This is propene, methyl propene. Now this is pretty good because when this does form the intermediate, it's gonna form a cation over here like this. The hydrogen will come over here and then the bromine will attack this. So this is a tertiary carbocation which is very, very stable. So 31 will be C. Propene is wrong because it's CH2, CH, CH3. It's alright, I mean, it's okay. This carbon over here, this one, is a bit stable. It's gonna form a secondary carbocation, but not tertiary, not as stable as methyl propene, okay? Because the intermediate is like this, CH3, CH, CH3. So positive inductive effect from two groups. Halogen alkanes react with hot ethanolic potassium cyanide. The reaction mechanism is either SN1 or SN2. Which statement is correct? All secondary halogens undergo no, no, no. They undergo both SN1 and SN2. Both the halogen alkane and the cyanide ion are involved in the initial step of SN1 mechanism. In SN1, the order of the reaction depends, the rate depends on the concentration of one reagent only, which is the hydroxide or the cyanide ion only. So this is wrong. If it was SN2, it would have been correct. Okay, B is wrong. Chloroethane reacts with cyanide by SN1. No. Chloroethane, CH3, CH2, Cl. This is a primary halogen alkane, so it should be SN2. This is wrong. The SN2 mechanism involves a short-lived negatively charged transition state. This is perfect. We get a short-lived state where, you know, basically the bond breaks with the chloride and the new bond forms with the cyanide ion, and on the other hand we have the other stuff lined up, like, you know, CH3 over here, hydrogen here, five, it has 5 bonds transiently. One is breaking while the other forms, and it has a negative charge due to the attack by the cyanide ion. D is correct. And for SN1, remember that the intermediate is a carbocation. Now 33 X1Z are 3 isomeric alcohols. Separate samples of each alcohol are warmed with a mild oxidizing agent, and the results are noted. One of these alcohols, when dehydrated, will give a pair of cis-trans isomers with molecular formula C5H10. Which row is correct? So this is primary alcohol, it will react. This is secondary, it will react. But look at Z. Z is actually like this. It's tertiary alcohol, right? It's a tertiary alcohol. So Z won't or can't be oxidized. But when dehydrated, one of these or some of these, or one of these only, will give a pair of cis-trans isomers. Okay. So it can't be Z, all right? Because look, if you bring it over here, it's not cis-trans because you have the two same elements attached to this carbon. Same goes for here. It will still be CH2. So that's gone. So then what do we have? What if we bring it over here? It's not possible since these two are the same group. So Z is a no-go. You're out, Z, as an answer because it can't give, you know, it can't give cis-trans. But look at Y. CH3, CH2, CHOH, CH2, CH3. After dehydration, what happens to Y? Suppose it goes here. Now, look at this. This carbon has hydrogen attached and an ethyl group. This carbon has hydrogen attached and a methyl group. So yeah, it does give a pair of cis-trans isomers. That's fine. So yeah, I'm gonna go with X and Y can be oxidized, and Y only gives us cis-trans isomers. Alright, so 33 is C. 34 compound G gives a pale yellow PBT with alkyne iodine. Four types of compounds can give positive iodoform test: ethanol, ethanol, all methyl ketones, and some secondary alcohols which have, um, an alcohol, a secondary alcohol with a methyl side chain. So pentan 1-ol is wrong. Let's take a look at pentan 2-ol. CH3, CHOH, CH2, CH2, CH3. This is pentan 2-ol. After you oxidize it using iodine, it turns into CH3, CO, CH2, CH2, CH3, which is in fact a methyl ketone. And as a result, it is going to give us a positive test. This is the secondary alcohol I was talking about. Look at this. It's a secondary alcohol with a methyl group as a side chain. That's why it's correct. 35. The mechanism for the reaction between ethanol and hydrogen cyanide starts with this step shown. This is nucleophilic addition. This is the first step. Afterwards, since this carbon can't have 5 bonds after forming this double bond breaks and a negative charge will form on the O. A is wrong. C is wrong. Negative charge falls on O. And we know that HCN basically is the reagent is HCN and the catalyst is KCN. It just provides cyanide. So the arrow will always be from, remember, the arrow will always be from the nucleophile to electrophile. I don't get it. What's the difference? They look like the same diagram. I am serious. Oh, okay, okay. It's over here. Wow. So yeah, it's a triple bond actually. So it has to be D. This is false. Okay, it's C triple bond N. Nitrile has this bond over here. Okay, the cyanide ion. And after it forms a bond with the carbon, it turns into nitrile. We call the group nitrile. And always arrows are from nucleophiles to electrophiles. Which compound reacts with 2,4-DNPH but not with toluene? Toluene is a test for aldehyde. 2,4-DNPH is a test for carbonyl. So we are looking for a ketone. Alright, we have our answer. It's A. All these other ones, these two are aldehydes. This is an alcohol. It is negative for both. Compound X has stereoisomers and forms a PPT with fillings. It's an aldehyde. So B is a ketone, C is a ketone. It's between A and D, and it has stereoisomers. Okay, so A is wrong because the same groups are attached, so no cis strands and no chiral carbons. But D has stereoisomers. It has a chiral carbon over here. Look, 4 different groups are attached. CH3, the aldehyde group, this long 1, 2, 3 propyl group, and 1 hydrogen atom that we can't see. So 37 is D. 38. Which reaction will form propanoic acid? Acidic hydrolysis of propyl ethanoate. Propyl ethanoate is this: CH3, COO, CH2, CH2, CH3. It forms propanol and ethanoic acid. Wrong. Alkane hydrolysis of ethyl propanoate. So this gives us ethanol and propanoic acid. However, since it is alkaline hydrolysis, the propanoic acid rather turns into sodium propanoate or something. CH3CO, CH3, CH2, COO minus Na plus or K plus, depends on the alkali honestly. So the alkaline hydrolysis is our downfall. Acidic hydrolysis of propane nitrile. So what is propane nitrile actually? CH3, CH2, CN. This is propyl nitrile. Acidic hydrolysis gives us CH3, CH2, COH. Really important, okay? It could be alkaline hydrolysis as well, but we needed acidification afterwards. So remember the two roots of nitriles. Nitriles can be reduced using LiLH4 or hydrogen plus nickel to form amines, and they can be hydrolyzed using acid or alkali, and alkali followed by acidification to form carboxylic acid. Very important. Okay, a nitrile has two roots. You can watch my AS organic chem video. I've described that really well. It has two roots. It can either be hydrolyzed to form an acid, or it can be, reduced to form an amine. Lactide is an intermediate in the manufacture of synthetic fiber, which compounds on heating with an acid catalyst can produce lactide. Okay, so this is typically an ester. So let's look for the ester bond. It's over here. So we are looking for a compound with 1, 2, 3 carbon atoms. So I'm just gonna copy paste this. All right, I'm copying it. So over here, I'm looking for a carboxylic acid over here, and here I have a CH3 group, and here I have OH group. I'm looking for this. This can uh, self-esterification can happen here, and a cyclic compound can form. This compound has 1, 2, 3 carbon atoms. So it is mainly propanoic acid, but on the second carbon it has a hydroxy group. So it is 2-hydroxy propanoic acid. See, carbons 1, 2, 3, 1, 2, 3. However, on carbon number 2 there is an alcohol group, 2-hydroxypropanoic acid. Last, the diagram shows the relative abundance of different isotopes of lead in a sample of lead ore. The abundance of 208 is half that of 206. The abundances of 208 and 9 are equal. What is the relative atomic mass of lead in the sample? So 50 times 206 plus, it is 50, right? Yeah. 25 times 208 plus 25 times 209. Let's do this. By 100, we should use by 100. 25 by 100 into 208 plus 0.25 into 209. So that gives me an answer of 207.25, which is B. So yeah, that is it. Overall, I'd say quite a hard paper. Quite a hard paper. I will be doing the other ones, paper 1.1 and 1.3 soon. Hope you like the content. And if you do like the videos, please do consider subscribing to the channel and supporting me on Patreon. Quick shout out to my top tier patrons. They are Pearl, Sean, Luna, and Dewa. If you guys want a shout out as well, please do consider joining the highest tier. You get access to all my solved question papers, all my notes, as well as video meetings with me to solve your individual problems. Alright, so I'm gonna link the paper for May-June 2023 paper 1.1 and May-June 2023 paper 1.3 when I solve them, and I'll link the playlist for chemistry paper 1 up here, and subscribe to the channel. See you guys.